The topic of strength of materials in torsion, we have some example here. So the example first is a copper pipe shown in the figure below has an outside of 3.5 inches and a wall thickness of 0.313 inches. The pipe is subjected to a uniformly distributed torque of 90 pound-feet per feet along its length. Using a length in A 2 feet and B is equal to 4 feet and C is equal to 8 feet, we need to determine the shear stress at A on the outer surface of the pipe. And for letter B, the shear stress at B on the outer surface of the pipe. So, we're talking about torsion. So, torsion is just equal to, in looking for shear stress in torsion topic, we have T with tau, which is represent for shear stress, is equal to torsion times the radius over the G, which is the polar moment of inertia. Now, before solving the problem, for everyone who is not capable of just looking at the problem, you need to write down the given, which is the best way for someone to locate on which part they will start. So, for torsion, we are given which is 90 pound per feet. But this torsion is not a single distributed torsion which is uniformly. So try to think of a cantilever beam which is being applied a uniformly distributed load, which is the same as like this. So next is the radius, but the radius not given, which is instead of radius, the problem gave us diameter, which is 3.5 inches. Now as we know that radius is just 1/2 of diameter, so we have radius is equal to 1.75. Also, we have given length, which is a total length of 2.5 plus 4, which is 6.5 plus 8 is 14.5 feet. So, another given, which is the thickness of the pipe, which is 0.313 inches. Now, we just only need the torsion, the single one, and the radius, the polar moment of inertia. Now, for polar moment of inertia, which is stated that is equal to pi over 32 d4 minus a small d raised to the power 4. For big D, it is the outer diameter minus the inner diameter. To locate the inner diameter, we need just only the outer surface diameter minus the thickness of the pipe, which is times 2. Now, instead of substituting this equation in the formula, we just only need to compute the value of the inner diameter, which is, we have a outer diameter of 3.5 minus 2 times the thickness, which is 0.313. Now we can have the inner diameter, which is 2.874 inches. Now we can solve the polar moment of inertia, which is G is equal to pi over 32 times 3.5 raised to the power 4 minus 2.874 raised to the power of 4. So our polar moment of inertia is equal to equal to 8.0343 inches. Now, we can solve the shear stress. But before that, we need to convert our uniformly distributed torsion into a single one. How? We need only to, from 90 pound-feet per feet, we need just only multiply this by the length which is being distributed. Just like in a cantilever beam, we need to multiply from C, the length of C to A. which is B plus C, which is given value, which is 8 plus 4 is equal to 12. So we need to multiply the 90 pound per feet into 12. So we have a torsion which is equal to 1,800 pound feet. But we need to convert feet into inches. Why? Because our diameter is in terms of inches, also the radius. So we need to times this, which is 12 inches is equivalent to 1 feet. So we will get our final answer for torsion, which is 12,960 pound inches. So we already have the torsion, the radius, also the polar moment of inertia. So we will just only input all the value from our formula, which is TRG, which is equal to 12,960 pound inches times, now the radius is 1.75 over polar moment of inertia, which is 0.034 inches raised to the power of 4. So our shear stress at A is equal to 2,822 pound secant squared inches. Now for letter B, so if you already followed my solution in part A, I will likely to erase this part here. So for B, same as what we did in A, the only difference is the length for converting torsion, which is we will just use only 8y from C to B, which is the length is C, which is equal to 8 inches. But our polar moment of inertia is the same. Why? Because they are the same material only. So our torsion will be 90 pound feet times 8 inches. 8 feet. So we have 720 pound feet. Same as we did, we need to convert it into inches. So 12 times 720 times 12. So we have a torsion of 8,640 pound inches. Now we're ready to solve the shear stress at B. So we have the shear stress formula equal to torsion, radius, polar moment of inertia. So we have a torsion of 8,640 times 1.75, which is the radius, times our polar moment of inertia, which is 8.0343. So we can get the shear stress at B, which is equal to 1,801.9 pound per inches squared. So for more videos, just subscribe in our channel.